Hey everyone, welcome back to POL 935, Computational Social Science. In this week, we're going to talk a little bit about the opportunities and challenges for social research in the digital age. So here's a brief outline of the videos that I'm going to post this week. In this video, I'm going to talk about three eras of survey research. And specifically, I'm going to talk about how the digital age changed public opinion research, and more generally, what these changes mean for computational social science more broadly. In the second video, we're going to focus a little bit on your own research ideas, and specifically, I'm going to get you up to speed to start planning your semester project. And then there's going to be a third video where I will talk a little bit about the first assignment that is due not next week, but the week after, and I'm going to start providing some hints and tips on how you can get started. So let's get into the three eras of survey research. So my own background is in political psychology, and I use a lot of survey research and survey experiments in my own work. So I wanted to give you a brief overview or a brief introduction as to how survey research changed with the digital age. Okay. So one of the required readings for this week was Grove's 2011 Three Eras of Survey Research. And this is just a short article that basically just describes some of the key points that we're going to observe in the upcoming weeks and throughout the semester, where we will discuss a lot of different research papers and new projects that kind of combine some of the characteristics described by Groves already in 2011. So the author kind of just describes the evolution of survey research and separates them in three broad eras. Okay. And the first era from 1930 to 1960 is the era of invention. So this is kind of where survey research kind of actually started. And a lot of these early data collection efforts were based on face-to-face interviews or mailed questionnaires, and only later, towards the end of that era, people, both researchers and private companies, started conducting phone surveys. And the author describes some of the challenges related to survey research during that time. One of the main problems in that time was not necessarily response rates or anything like that, but it was rather how to actually get a reasonable sampling frame to make inferences about your population of interest. So sampling frames back then were oftentimes based on area, with face-to-face interviews, for example, a neighborhood, and then you would, kind of start interviewing people in a specific neighborhood. And so the selection of the sampling frame was limited and was one of the key problems to actually achieve representative samples. And also because it was quite labor intensive, most of these samples, most of these data collections were relatively small, especially with face-to-face interviews. Okay. But the key point is at that stage early on, compared to later stages, as we will see, at that time no one really worried about survey non-response, so people refusing to participate in surveys or things like that. Okay. Then the 1960s through the 90s are the era of expansion, and this period was kind of the golden age of phone surveys, where a lot of people had landline phones, and you could easily use, for example, techniques like random digit dialing to get a true probability sample of whatever population you're interested in. For example, nationally representative populations, for example. Based on phone records or the combination of phone records and random digit dialing So the challenges here changed a little bit. It wasn't sample size and the sampling frame anymore. The sampling frame was actually much better than compared to area-based sample selection. But new challenges came. For example, people interrupted or stopped interviews. There were issues with partial interviews, that people declined to continue an interview. Questions about missing data or declining, and also declining response rates at the end of that era. But more important for our discussion, and this is kind of just the historical background, and we're not really going to talk about those earlier eras anymore. But what is key and what is most important for us is kind of the new era, starting with the 1990s to the present. And again, this article was written in 2011, and a lot of these developments only were only further exacerbated essentially. But Groves calls this era, or this latest era, the designed data supplemented by organic data. And what the author means by that is that the way we collect data, or survey data in particular, changed due to a lot of technical changes and technical developments. People have much fewer landlines. A lot of people have only mobile phones and are therefore much harder to reach, both because they can just decline calls, and also because the random digit dialing based on area code doesn't really work the same way anymore. So in that context, there were fewer and fewer phone interviews, or they're becoming less and less common, and instead there's a move to opt-in internet panels and data survey collection through those. The challenges that are related to that are, on the one hand, we have deteriorating response rates. So a lot more people kind of decline and are kind of are not willing to participate in surveys, which of course has if you're interested in ultimately making inferences more about a population, you need some kind of representative sample. So that's becoming more and more difficult. And especially when you're talking about opt-in internet panels, you have less and less control over the sampling frame. So it's less certain exactly to what extent you can directly extrapolate from your sample to the population. But the key point is that this era is not only facing new challenges. There's more and more talk about surveys being more and more flawed because of declining response rates and all of these things. And of course, these problems do exist. But the key is that there's also a lot of opportunities. And the opportunities in particular is that we have a wealth of additional kind of meta information that is potentially available and that can be used in conjunction with survey data. And this is the key kind of element of this combination of design data supplemented by organic data. So what is design data and what is organic data in this context? Design data is the data, if we think about the context of survey research, is basically data that is created by like a conscious data collection effort in order to gather certain information. So the example is questions asked in a survey. They're asked for a specific purpose by the researcher who are actually interested in answering a certain question, and therefore kind of designed with that goal in mind, okay? So given that they're designed for the specific purpose of, gathering information, for example, about households or about people's attitudes, the ratio of information to data, so to speak, is very high, right? So basically you have all the information in your survey that you need in order to answer your question, because, you designed the survey specifically in order to answer that question. So you can directly use the estimates that are made from each data item, like a survey question. But as we saw, given technological developments and given how there are declining response rates and fewer and fewer people willing to participate in these surveys, they're increasingly rejected by sample persons, which is a fundamental problem with design data or surveys in that context. So how can organic data help us, or what exactly do we mean by organic data? Essentially, organic data is those are any types of data that are collected not specifically with that research purpose in mind, but that are kind of auxiliary data that are produced as part of being online, logging onto social media, and things like that. So those could be call logs or information about internet traffic, or information about things that are shared on social media and things like that, right? The key thing is that the underlying data and how much information there is, or the ratio of information to data is very low, right? So there's just huge amounts of data that are being collected by companies or and things like that that are not directly collected with like a research purpose in mind, but potentially at least some of those can be used in order to answer substantively interesting research questions, right? But the key is that there's more data available than exactly what we need, and oftentimes it's not coming in the right format, or it's not exactly in the not distilled down to just the information that we need. So one of the challenges is kind of identify what information is useful in a specific research context, and then be able to kind of extract that information. And there are also new challenges related to that, specifically ethical challenges, especially when it comes to privacy. So in the article, Groves kind of concludes. Let's see if I can move myself for a second. Let's see if that works. One of the conclusions in this article is that the challenge to the survey profession is to discover how to combine design data with organic data. So how to kind of combine particularly collected data for the purpose of a research project with other kind of auxiliary information to kind of gather new insights. Okay, and that's kind of the exciting new opportunities, or those are the exciting new opportunities that are coming with the digital age. And throughout the semester, we'll read more and more articles and talk about more and more research that kind of achieves this combination of, on the one hand, design data, and on the other hand, organic data, like digital trace data and things like that. All right, I'm going to move myself back down here. I hope this works. So as I said, throughout the semester, we're going to talk a little bit more about different examples that kind of combine these different types of data. But one example that I want to talk about right away, that is also mentioned in the Bit by Bit book right in the introduction, is Blumenstock et al. 2015. That's a science article. I also actually posted it. It's not a part of the required readings, but I posted it on Canvas in case you want to take a look. It's a short article, definitely worth a read. It's titled Predicting Poverty and Wealth from Mobile Phone Metadata. And this is a really great example of this combination of one kind of designed data for the purpose of, like a survey, for example, and additionally auxiliary, in this case, call logs, data that is basically provided by phone providers or collected by phone providers in order to answer a substantively interesting and really, really important question. So specifically, what the authors are interested in is estimating poverty and wealth in Rwanda in smaller geographic communities, which is basically these types of data are very difficult to collect and very expensive to collect. And so this is like to have a better, more fine-grained estimate of local wealth and local poverty can be really important for example, policymakers and things like that. Okay, so what are they actually doing? They have two types of data. On the one hand, call records, which is an example of this organic data. This is just the data. These are just data that are collected by phone providers. And then they have a survey. They ran a survey with people in Rwanda. The idea ultimately what they're trying to do is they're trying to combine the survey data with these call records. And the call records themselves are just logs of calls, of connections between phone numbers. And so one crucial step, and I'm not going to go too much into the details, but one crucial step is there's a lot of information in these call records, right? You have times of calls, what types of connections, the locations, length of phone calls, frequency of phone calls, are there international calls and things like that. So there's a lot of different features, so kind of pieces of information that are in there that you can kind of connect to each individual phone number. So what they've been able to do is basically run a survey with a sample of people and ask them key questions about income and the outcomes that they're ultimately interested in. They're interested in estimating wealth. And they were able to combine that with the information from the call records to estimate a model that kind of connects, on the one hand, the features in the call records and the information in the survey that they estimate, right? But the fascinating thing is that they don't stop there, right? Ultimately, what they do is they want information for a lot more people, but of course the challenge is they can't run a survey with the whole population in Rwanda or a larger sample or even if you think about updating this the next year and things like that. So the idea is based on the learned relationship between the features in the call records and the survey responses in the survey that they actually ran, they can then kind of impute the information that they didn't collect about people that they didn't ask based on what they can observe about their call records. Okay. And then on top of that, they know they have information about people's residence location. And so by kind of in addition estimating people's residence location based on the call records, now based on that model, they can basically just use the call records to make predictions about wealth in small geographic areas in Rwanda that in otherwise would be very hard, very, very difficult to collect. Okay. And this is one of the plots from the paper where they basically look at the relationship between, on the x-axis we have, let's see, down here, we have predicted wealth. So predicted based on the call records, and here we have actual wealth measured in the survey, and we see that they're able to relatively accurately predict the actual wealth based on the call records that they gathered. And this is another plot also from the paper where they then looked at the average predicted wealth in individual districts computed from call records and the average household wealth computed from DHS. So that's the Demographic and Health Survey in Rwanda. That's kind of the benchmark that they're using, all right? And so what they're showing is that based on their call records, they have a pretty accurate prediction of household wealth in specific districts that kind of matches the survey information, right? But the key thing is that, or the key advantage is that this is on first 10 times faster and 50 times cheaper than running a survey every year to get fine-grained information about wealth or poverty in specific districts. So this is a key example where we have this combination of organic and design data. And so this kind of brings us back to kind of this broader question that I started one of the first videos with, which was this question about what is computational social science, right? And back in the first video, I answered this question by saying that computational social science uses computer-based techniques to analyze the rapidly increasing amount of data produced via digital sources or currently being archived in digital form, right? So this is a prime example, or the Blumenstock paper is a prime example of kind of that part. And the key is that when we're talking about computational social science, or a key thing to keep in mind is that it's not only that computational aspect, right? It's computational science, but it's also social science, right? It's not only the availability of new data, but it's combining that with a survey and combining that with insights from social research to actually gain new insights. And in the Groves article, the Groves article is talking about this distinction between organic data and design data. The equivalent in the bit-by-bit book is this idea of combining ready-mades and custom-mades. Okay, that's basically the same idea. There's this these two nice illustrations. Where the ready-made is kind of the equivalent of the organic data, in the sense that this is a sculpture based on a urinal, and of course the idea is that we're repurposing something that was produced for some other purpose, but now we're using it for something else, right? And this is kind of the idea of using call logs or call records now in order to answer a specific substantial research question. And that is in contrast to custom-made, so the design survey that was specifically designed for the purpose of answering a specific research question. And the unique thing about computational social science, the way we think about it, is that it combines these two aspects, the ready-mades and the custom-mades. And that's where the most exciting research is essentially happening. But, and this is also an important kind of aspect that we're going to talk about throughout the semester, is that it often raises complex and problematic ethical and specifically questions about privacy. We're going to talk about that at length throughout the semester as well. All right, and I have to move myself a little bit again. And the other thing that is important to keep in mind, and how this is kind of different from class or traditional social science research, is that it involves multiple communities. So in our in the case of the Blumenstock paper, they had to rely on call records that were collected by phone providers, right? And so these are, you could think of other research collaborations with Facebook or with other companies. And the key thing is that there are different communities that are kind of either part of the research process or part of the data collection process. And so in general, computational social science involves more than just the researchers, but involves social science, it involves data science, it involves business people, privacy advocates, policymakers. And so all these groups have different interests and these interests kind of have to be kept in mind, and also ideally, align so that some useful collaboration, productive collaboration can be achieved. All right, I'm gonna speed up here a little bit because I don't want this video to be too long. But just to answer the question, well, isn't this just a fad? Isn't this just a new thing that's not gonna stay? The short answer is no. Um, but also, we can back this up. These are some figures from the book, and this is just data until 2007, actually, where we see how both information storage and computing power over the past 20 years increased exponentially. So these are fundamental and systematic and systemic changes that are there to stay. And so social science kind of has to adapt to these changing environments, and therefore computational social science is not just a fad. It's kind of the discipline adapting to a structurally changed environment. Okay. Um, Another question that you can ask, or that we can ask, well, if this is the case, shouldn't we just all be data scientists, or do we still need social science, or can we just abandon social science and just all study data science? And again, I guess the short answer, of course, is no. But the slightly longer answer is well. First, we want to talk a little bit about what is data science and what does data science entail. And this is kind of one of the classic Venn diagrams of what data science is. On the one hand, we have math and statistics knowledge. We have substantive expertise and hacking skills. And data science is kind of the intersection between those three. Those three areas. But still, there's room for social science, because social scientists bring more substantive expertise, specifically in the area of social research, than data science necessarily have, right? So if we kind of compare in this context data science and social science, data scientists in general could basically study anything. And usually, if you look at data science research, it's oftentimes very methods driven, and it just focuses on large found data. But specifically, it's usually focused on prediction. And the focus for social scientists is usually a different one. Social scientists, of course, by their very nature, we study social things, social questions. And so we're usually driven by those questions and not necessarily by the available methods, although, of course, this can be bidirectional too. And we often, as I kind of described, often, at least in the traditional research, kind of focus a lot on small design data like surveys and things like that. But a key distinction to data scientists is that we're more interested in explanation and not necessarily so much interested in prediction. We're interested in testing causal hypotheses and things like that, rather than just having the best the most accurate possible prediction of some outcome of interest, for example. So overall, what we can say is that data science alone is not enough if we want to study social behavior, and at the same time, social science alone is not enough if we want to use these new data sources that the digital age kind of is bringing with it, which is necessary in order to kind of answer or to adapt to the challenges. Thinking back to these three eras of survey research, if we want to be able to adapt to those challenges, then we need new data sources. We need to incorporate designed, sorry, not designed. No, what was the other? not design, but found data, auxiliary data. And if we want to be able to incorporate that, we need data science and we need computational methods. All right, I think this is it. In the next video, I'm going to talk about brainstorming research ideas.